Turn down for what? So what is the differential equation? A differential equation just has dy dx embedded in it. When you get to the university and if you become an engineer like Ms. Price here, Ms. Morales, you're going to take a course called differential equation. And Ms. Houston,
No, I'm just saying I'm not gonna be an engineer.
you're going to be an engineer. Trust. It's because I look to the right and you're down here, and they're to the they're at Stop. No,
okay,
stop.
I get it.
Miss, you're going to be an engineer. Trust. All right. You're going to take a course called differential equations, and that's where you're going to have second order and higher order equations. You're going to do something called Laplace transforms. Maybe you can Google it later on, Laplace transforms, and you can see we're not dealing with second order equations, or at least not for the most part. All these are going to be pretty straightforward. They're going to be the simple ones. So we'll let your professors take care of that course when you guys get there. You've already done a whole bunch of these. You don't even know it yet. Usually they're all with one variable. So it says find all functions y that satisfy dy dx equals secant squared x plus 2x plus 5. You've done this already. So pretty much what we're trying to say is, what's the antiderivative of this expression? What's antiderivative of secant squared? So tan x. What's antiderivative of 2x? X squared. What's antiderivative of 5? And then and then I put plus c for some constant c, where c can be any constant. And later on, we'll talk about slope fields and all that good stuff. And relax, it sounds hard, it looks hard, but it's not. It's not that bad. All right, and that's it, guys. That's what you guys have been doing for a long time. Maybe you've also been doing something like this with initial problems. It says find a particular solution to the equation, blah, 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 with graph passes to the point 1, 0. So again, same thing. I want a specific equation. Antiderivative of e to the x is e to the x, and then antiderivative of 6x squared, 2x cubed, right? Add 1, divide by that number. And then I put a plus c, and then I use this initial equation to give me my c. So that's an x, this is a y. So I'm going to write 0 equals e to the 1 minus 2 times 1 cubed plus c. So from that, let's move everything to the left here. So we're going to get, 2 minus e equals c, and there it is. So I'm going to write y equals e to the x minus 2x cubed plus 2 minus e, and this is that particular equation. We already have a lot of experience with that. I think you guys are good with that. What is new? You probably, if you've done a lot of flashcards, which I already saw that 5 of you are already on the leaderboard, so some 3 of you already have plus 400 attempts. So you've already accomplished enough flashcards for a whole month. No, I think you just hit it. Attempts. Your score is different, but yeah. I think there's 3 of you now. 1, 2, 3. So guys, this is probably the best start we've ever had to flashcards. So maybe we'll have the whole class get 5s. All right, we're going to be doing something called separable differential equations. Like I said, you probably already came across it. All that means is that you have x's and y's, and all you're going to do is you're going to get the x's together, and you're going to get the y's together. And then to get rid of the dx and dy, you're just going to integrate. Not all differential equations are separable. Not all of them. Yes, that's what I was saying. That some of the flashcards already had some of these, so some of you guys are probably already experienced with them through that. So here it is. Here's an example of a separable differential equation. It says solve by separation of variable. You must do this on your AP exam to get any credit. If you don't do this first step, you're not going to get any credit. So ready? So I'm going to write dy dx, and I'm just using the law of exponents, x squared, y squared. So now what am I going to do? I'm going to get the y's together. I'm going to get the x's together. So see that y squared? I'm going to divide by y squared. And when I divide by y squared, it's going to go down here. And then I guess I should have done it in the blue color. And then I'm going to multiply by dx, and whatever I do to one side, I do to the other. And usually you want to have the dy and the dx at the end. So maybe write it like this. I'm going to write 1 over y squared dy equals x squared dx.
In the questions we had, it kept dx and dy together. Why is that? I feel like they just separated.
Yeah, you're supposed to separate it.
No, but I feel like they just separated the values, not the dy yet.
Well, they probably just did the antiderivative immediately to get rid of it. So that's going to be the next move, guys. I want to go ahead and get rid of the dx and the dy. So I'm going to integrate, and that's how you get rid of the dx, the differential, by integrating. See? So this, remember, this is just y to the negative 2. So the antiderivative of that is negative 1 over y. And you could put plus c, but there's no reason to. Well, I guess we'll talk about that. I guess don't write this down. Just write. Don't write this down. Just observe. Plus c1 equals, and the antiderivative of x squared is x cubed over 3 plus c2. But then don't write this part down. Just listen. If I move the constants together, minus c1, well, c2 minus c1 is just some constant. Does that make sense? So because it's just some constant, you just disregard it and just put it on one of them. So usually, what's the common practice? Usually to put it with the x. Why with the x? Because that's the one we always hit up. Does that make sense, guys? Okay, that you can write. Yeah, don't hit up the x. Not in real life. Because that's just asking for trouble. In all my years of life, guys, I've only heard of one case of a couple that divorced, and then like 30 years later they married again to the same. That's the only. I've only heard of one. See if you can find others, but if one out of billions of people, if it's only happened once, yeah, you're probably asking for trouble going with an X. So don't. All right. I like to solve for my C right here. Other professors and and teachers, they might want you to solve for Y first and then solve for C. I think it's easier, this is my opinion, I think it's easier to just hit it right here. Does that make sense to you? So I'm just going to plug in right off the bat. X is 1, Y is 1, so I'm going to go negative 1 over 1 equals 1 cubed over 3 plus C. Negative 1 equals 1/3 plus C. Minus 1/3 minus 1/3. Negative 4/3 equals C. Because that negative 1 is just like 3 over 3. Does that make sense to everyone? So then I take the C and I come back to this one right here. Negative 1 over y equals x cubed over 3 minus 4/3. Bless you. Bless you. Negative 1 over y, since the denominators are both 3, I'm going to write it like this. X cubed minus 4 over 3. Are we still okay? Because I have a fraction, I can just flip both of these. See? Look, there's a negative there. Negative y, that's what y divided by negative 1 is, equals 3 over x cubed minus 4. Because I want to solve for y. That's what I'm looking for. Solve for y. Yep. Y equals negative 3 over x cubed minus 4. And you're done. There are other ways to do it. It depends on you, it depends on the professor, and it depends what you like. How do we feel? Okay. All right. Let's do some problems. You guys already see what's going to be coming up next. Yes. You guys are. Yeah, well, but those were from spring break, though. But yeah. All right, relax. We're going to go slow. Use the integration to find the general solutions to differential equations. So they probably means that they want you to solve, like they want to see the steps. Even though it's all multiple choice, you can't really see the steps. Distribute this first. dy dx equals 4x squared minus 4x. All right, take the antiderivative. Y equals 4/3 x cubed. I wrote it as 4x cubed over 3, whatever you prefer. Minus 2x squared plus c. Let's look for that. Is it in there somewhere? Letter A. That's it. That's it. Yeah, we got the easier differential equations. Later on, you'll be using Laplace transforms, but we'll wait for your college days for that. Are we still okay? All right, this one has x's and y's. So group the y's with the y's and the x's with the x's.
What?
So,
Just like out of curiosity,
to be able to integrate to get the differential out. You know what I mean? Like this, watch. Y plus 5 times y plus 5, and then times dx, and then look, you get this. Y plus 5 with a dy equals x minus cube with a dx. See? Yeah. So, because you can't integrate different variables. Well, you can when you get to Cal 3, but right now we're in Cal 1. We're just doing one at a time. So you can only integrate the y's with the y's and the x's with the x's. Yes. When you get to multivariable, you'll be able to do Fumini's theorem, which means you'll be able to do multi-integration with different letters. When you're doing partial derivatives, but we'll wait for Texas Tech to hook you up with that. All right, here we go. Antiderivative, guys. That's how you get rid of that differential, the dy and the dx. So here we go. Antiderivative of y with respect to y. Y squared over 2 plus, no, be careful, 5y, because this is with respect to y, equals antiderivative of x squared over 2 minus, and then plus c. Well, before that, look, you see all these fractions? I mean, all these a, b, c, d, e's. Do any of them have fractions? So I'm going to multiply the whole shebang by 2. And by the way, anytime you multiply a constant by 2, you're not going to write 2c. 2 times a constant, is it still a constant? So you're going to write c. So that's the biggest thing. Yes. The c stands for constant. It is not like, you're not going to say like, this is a number. It's just some, yeah. So 2 times a constant is still a constant. So here we go. I'm going to have y squared plus 10y equals minus, and then instead of writing plus 2c, I'm just going to write c. Put in there, it's just a constant. We'll let the situation tell us what that constant is. All right, move everything to the left and leave the c alone. So I'm going to move that to the left, that to the left. So let me see what I have. I have y squared minus x squared plus 6x plus 10y equals c. So let's look for that first. Is it in there? Yes. Is it C or D? It's C, right? There it is. How are we feeling so far? Okay. Anytime there's any type of models, because you don't have to have them in terms of x and y, right? Like it just depends on the model that you have, and then you're trying to solve for a specific model, like y equals whatever. I mean, I don't know. It just depends on the situation, like the real life situation. We're gonna be doing slope fields pretty soon, and you see them all the time on the weather channel. You know, the weather people, what do they call it? Meteorologists? They take calculus. They have to, so they're actually pretty knowledgeable. Not that they're not, right? All right, example 6, guys. Use integration to find the general solution. Okay, y's with the y's. Divide by y, divide by secant y, divide by secant y, times dx, times dx. So here's what I have. Dy over secant y, in a little bit we're going to use trig to help us out with that, equals 1 over x minus 3 squared dx. Are we still okay? What's up, Ms. Cobb?
Do you prefer us to put it like that, or do you prefer us to do 1 over secant y times dy?
Oh yeah, 1 over secant y times dy is probably better. All right, since I have the secant y in the bottom, if I bring it up, it just turns to a cosine. All right, I'm ready, or we're ready. Antiderivative of cosine y. No. Just sine. The derivative of cosine is negative sine, but the antiderivative of cosine is a positive sine. Equals. No, because there's a square right here. This is a linear expression. Negative. It's not an ln. Ln's only when you have a linear expression. I don't have a linear expression. I know I did say linear expression inside the parentheses, but it's not linear. There's a square there. It's quadratic. So this is, I guess you could do u substitution if you want. U equals x minus 3. So du equals dx. So this is like saying integral of 1 over u squared du. Negative 1 over x. Negative 1 over u. Or negative 1 over x minus 3. Plus c. Right? Because 1 over u squared, that's like u to the negative 2. Add 1, divide by that number. We're still okay, guys? Yeah, this is what spring break does to us, guys. If you don't practice, we get rusty. So after the AP exam, you can do whatever you want. But, well, let's make sure that we're constantly practicing. What's the answer? B. There it is. And then here are the type of questions you'll be doing today. See, they're not that bad. Don't worry, we're only going to do 3, I think. We got 4. We're just solving. Let's see. In this one, we're solving. What is a particular solution? So we're looking for an actual model, the y equals. When it says particular solution, that means they want y equals something, or f of x equals something.
I saw it today too. It's just gonna be like today.
Yeah. All right, so here we go. Ready? Group the x's with the x's and the y's with the y's. So I see 2 minus y with a square on it, so I'm going to divide. So I'm going to have this. Oh, I skipped the first question? Dang, okay. I didn't mean to, sorry. Given the differential equation, dy dx, find a particular solution. Particular solution, so they want f of x equals something. All right, you guys ready? X with the x's, y with the y's. Times y times y. Y dy equals times dx. So I like to put a parenthesis on it. You don't have to put a parenthesis, but definitely put the dx at the end. Are we still okay? Okay. Integrate. Antiderivative of y? Y squared over 2 equals antiderivative of 2x minus plus. I like to plug in right here. Everyone is different. I see this 2, 4. I like to plug it in right here. Your professor might want you to solve for f of x first with a plus c and then plug in. It just depends. You're right. I'm dyslexic. No, I think I am. I just was never diagnosed because I've been doing this mistake since elementary. I remember. Okay. Anyways, x is 4, y is 2. Is that dyslexic or? All right. Here we go. Deja vu. All right. I'm plugging in. 2 squared is 4. 4 divided by 2 is 2. Does everyone know where that 2 came from? Okay. What's 4 squared? Minus, and then 5 times 4? 20. Yep. So 2 equals negative 4 plus c. There it is. 6 equals c when you do plus 4 plus 4. So I take that c and I come right to that one. So here it is. I'm rewriting it again. Y squared over 2 equals x squared minus 5x plus 6. Now, I don't want to leave it like this. Well, no, because sometimes we can, but this time we can't because look what they say. They want y equals or f of x equals. So here we go. I get rid of that 2 by multiplying by. So whatever you do to one side, you do to the other. So y squared equals 2x squared minus 10x plus 12. All right, what's my last move? Square root. Be careful. Plus minus. In a little bit, we'll choose one. Oh, okay. I would write the plus minus on this one all the time, and then we'll decide which one. Are we still okay? All right, which one am I choosing? Am I choosing the positive branch or the negative branch? The positive. Chop, when would I ever choose the negative branch? What if I had f of 4 equals negative 2? If I had that, then I would have to choose the negative. Does that make sense? So make sure it just depends on your model, on your situation. So be careful with that. So it's a positive one. So here it is, my last step. I'm going to write f of x as my last step. You don't have to. You can probably be fine writing y equals. Nope, that's it. Just that. Ask.
Would it matter if both of the coordinates were negative?
What do you mean by both? Like x equals negative 4?
Yeah.
No. As long as the output is negative, then we would have put a negative in the front. You got hit me with some more, guys. Are we okay? All right. Let's go.
Yes, we're okay.
Perfect. Thank you, miss. Let's go to the next one. This is the one that I didn't agree with, so I put the answer here in the bottom. Yeah, okay. And AP has done this too, so this is why I'm not a fan. What is this called? Like improper or proper? I'm not the technical guy. See, I have a fraction, and then within the fraction, I have another fraction. I'm not a fan of that. I never have been. Delta takes it. I've seen College Board take it. I've seen the rubric of College Board says, here's the answer. So I'm going to do it the way Delta does it because I think you guys like to look at their notes every time you submit. So that's fine. But I'm not a fan of it, but that's fine. I think professors would probably not be a fan of that either. I'll do it both ways. I'll show you where I would do it different. All right, what is the particular solution? So again, particular solution, they want f of x equals something or y equals something. Here's my initial condition. Notice the output, negative. Okay, so just in case we have to do square roots, so just notice the output. All right, y is with the y's, x is with the x's. So here's what I'm going to write. 1 over, parentheses, 2 minus y, close it, squared dy, or you can say dy over that if you want, equals e to the x plus 2 dx. Is everyone okay with that first step? Okay. I'm going to take an antiderivative, so I'm going to write integral. Hopefully we are okay now. Well, let's make sure that I don't make a mistake first. Remember, guys, this is not going to be log because it's square. There's a square right there. So if you need to do u substitution, do u substitution. It's going to be 1 over 2 minus y, negative on the outside, but then negative times a negative is going to turn into a positive, equals, because it's a negative y, not a positive y. Negative 2 plus 1 is negative 1 divided by a negative. Okay, I'll show you. Let me write it, guys. U equals 2 minus y. Du dy equals negative 1. So du equals negative dy. Do you guys see that? Yeah. Put a negative here, put a negative on the outside. I'm doing u sub. I'm going to erase it a little bit. Negative integral 1 over u squared du. If I pick this up, that's u to the negative 2. So negative bracket, add 1, divide by that negative. Negative 1 over u. See? Negative times a negative? Positive. So, okay, I'm going to erase all of that now. So I can go back to the problem. Oh, man. What's up? Hit me. Oh, you okay? All right, so let me erase these little minuses. So this is going to be 1 over 2 minus y. And I always make mistakes. Hopefully I didn't make a mistake there. E to the x plus 2 plus c. Right? Okay. I like to solve for right here. This because I think it would be a pain in the butt if you make a mistake and then you get the wrong c. But at least here you get the right c if you get it. I don't see any issues right now. I guess they're being nice. Negative 2, they're both the same. So here we go. 1 over 2 minus a negative 2, that's going to be a fourth. Negative 2 plus 2 is 0. E to the 0 is 1. So 1/4 minus 1 equals c. So what is that? Negative 3/4. I'm going to plug that in right there. So here we go. 1 over 2 minus y equals e to the x plus 2 minus 3/4. Are we still okay? Okay, I'm trying to get the e to the x plus 2 by itself because I'm trying to get x by itself. I'm trying to get y by itself. What am I doing?
Why did you not square the 2 minus y?
I did antiderivative. Add 1, divide by that negative. Okay, I'm trying to get the y by itself. Sorry that I confused you guys by saying x. So you see how I have a fraction here, 1 over 2 minus y? I'm going to put all this all over 1. And all I'm doing is just geometry, or a over b equals c over d. I can just flip it. So because I have this equal sign, I can just flip this. 2 minus y over 1, so you guys can see, equals 1 over e to the x plus 2 minus 3/4. Are we still okay? Okay. 2 minus y over 1 is just the same thing as saying 2 minus y, so I'm going to erase this over 1. I'm going to move the 2 to the other side. So that's going to be subtracting 2. So negative y equals 1 over e to the x plus 2 minus 3/4 minus 2. Are we still okay? And I'll slow down. Yeah, I'm slowing down. I'm slowing down. How do I get rid of that negative y? Change the polarities, divide by -1, multiply by -1, however your teacher taught you. So here it is. Y equals, change the polarities of everything on the right-hand side. 2, I'm putting that on the front, minus 1 over e to the x plus 2 minus 3/4. I'm assuming that's the answer they got. Yeah, lame. Okay, let me show you where I would have made a difference. I'm going to put a star here on this one. So here it is. I wouldn't call it the Chavez way, but like what I would like. You guys ready? I would do it like this. 1 over 2 minus y, and then equals e to the x plus 2 minus 3/4. I would do a common denominator right here. See how I have 3/4? So I'm going to multiply this one by 4 over 4. Are we still okay? So then I would go 1, let me go back to the purple. 1 over 2 minus y equals 4e to the x plus 2 minus 3 over 4.
And then from there, you would have
Flip it.
multiplied
I could, yeah, you could do that. I was going to flip it. 2 minus y equals 4 over 4e to the x plus 2 minus 3.
So they don't have common denominators or numerators?
No, they'll take it. I mean, as long as they're equivalent, you know what I mean? And then change the polarity. And I'm actually tempted to do a common denominator with the 2, but no, I'll leave it. 2 minus 4 over 4e to the x plus 2 minus 3. Those are equivalent. Delta math will count both correct. I think delta is just trying to give like what kids think is the easiest route. I guess you could have gone common denominator here. Keep, change, flip with the 4 on the top. You know. Are you cold, really? I was gonna offer you my sweater, but it has shaving cream from Alfaro getting pied. I gotta go wash it. All right, is this the last one here? Oh, we got 2 more. Yeah, 2 more, guys, and then we'll call it a day. Yeah, we're almost done. I know, brutal. Hey, you haven't yawned today.
Oh, I actually did.
Oh. Okay. I'm just gonna write like 10 demerits on your senior letter. Just put them all in there.
Mind you, I'm not the only one.
Instead of one of the billboards, they're like number of days until someone like counts.
If I had unlimited funds, I would write billboards all over the city. Today, Miss Kyle has yawned in my classroom. But unfortunately, I'm a teacher on a teacher salary, so I can't afford. Well, maybe one of these days. All right. Consider the differential equation dy dx equals x squared y squared with a particular solution. Have an initial condition. So here's my initial condition. Let me change it to red. -3, 1. Use the equation line tangent to the graph of f at the point -3, 1 in order to approximate the value of -2.8. I love it. So here it is, miss. We're using our model, a tangent line model, to predict what this value is. So first, find tangent line.
So now you can find a constant, and then one of the other variables, you plug in a -2.
Wait, let me read it. What it says: consider the differential equation with a particular solution have an initial condition. Use the equation of the line tangent. Oh, I just want the tangent line. Okay, what do I need for a tangent line? Point and slope. Do I have a point? Yes, -3, 1. Do I have a slope? Not yet, but do I have information to get the slope? Yes, dy dx equals x squared y squared. So I'm going to write dy dx, put a little line, that means evaluated at -3, 1 is equal to, parenthesis, -3, close it, squared times 1 squared. -3 times -3 is going to be 9, and then 1 times 1 is 1. So my slope is 9. And I'm going to write y minus 1 equals 9, parenthesis, x minus a negative 3. So it's going to turn to a plus. There's my tangent line. You're going to use this x coordinate. I'll slow down because I can see some of you guys still writing. I want to approximate negative 2.8. Like, what's my y value? So I use this tangent line to approximate. I'm going to put that negative 2.8 right smack in there. Sometimes you have a calculator, sometimes you don't. It just depends. Let's see if we can do this without a calculator. Y equals 9 parentheses, negative 2.8 plus 3, close it, plus 1. It looks like we can without a calculator. 9 parentheses, negative 2.8 plus 3. I think that's positive 0.2, right?
1.18.
Perfect. 9 times 0.2, that's 1.8, right? Or is it 0.18? 1.8? Okay. Plus 1, so 2.8. There it is. That's my approximate. And that's what you're going to be doing today. Yeah, it's not bad at all. We got one left, and we'll call it a day. Oh, ask. Yeah, that's correct. 9 times 2 is 18. Move 1 decimal to the right, 1.8. All right, here we go. Ready? The quantity of substance can be modeled. Yeah, see, like what if we have a substance, right? You'll see tomorrow we'll do applications. A whole bunch of applications. Good stuff. All right. Oh, don't worry, miss. I'll turn it off right now. But I kind of like it because it filters the air. It's not so muggy. Okay. The quantity of a substance can be... okay. We're not in Alaska. You don't have frostbite in your hands. Like... Okay, there's it's not a blanket, but there's like weights. It's a weighted blanket. Go put that on top of you and you'll feel warmer. It's in green. Miss White brought it. The quantity of a substance can be modeled by the function h of t. I don't know what's going on with my class guys there. That satisfies the differential equation. So here's my differential equation. 1 point on this function is, so here's my point, 1 comma 720. Based on this model, use a linear approximation to the graph of h at the t equals 1 to estimate the quantity of the substance at t equals 0.9. Okay, I want a tangent line, point and slope. Here's my dh dt equals 1 over 80 parentheses, and I'm solving for this when h is 720. 1 comma 720. This says h, it doesn't say t, so that's why I put that in here. 720 minus 160. What is that? 180 times... Oh, you already did it? Oh, no. 720 minus 160, what is that? 560? Oh, yeah. How many times does 8 go into 56? So this is 7. I like it. No, 7, 8. All right, here we go. I got my slope, and I'm going to get my tangent line. So y, really it should be an h, but we'll just write y. I didn't do upper minus lower. I just plugged in h. You know what I mean? I'm just finding a tangent line. What two things do I need for a tangent line, Miss Houston? Point and slope. Here's my point. This is how my slope is modeled, and I put this in here because most of the time the slope is modeled by the x value, but this time it was modeled by the y value, the h. So you have to plug in your initial condition. 720 goes right there to get the slope. You know what I mean? Okay. Y minus 720 equals 7 parentheses x, which is really a t, but that's fine. X minus 1, close. And what value am I going to plug in for x or for t? 0.9, right there. So I'm going to write h of 0.9, that's like my y here, equals 7 parentheses 0.9 minus 1, close, plus 720. I should put an approximate, but we're fine. Let's see, 7.9 minus 1, what is that? Negative 0.1, right? And I should write 0.1 plus 720. And then 7 times negative 0.1, that's negative 0.7 plus 720. So my approximate temperature? Yep, 719.3. And I'm assuming this is degrees. No, they don't tell me. It just says that's a temperature. So, all right, that's a temperature of something. Is it a temperature or is it a substance? That's a quantity of substance of something. Sorry for playing degrees. I don't know why I'm thinking of a problem. That's why. All right, guys, we're done. Take a break if you need a break. I got you, Miss Houston. That's a demerit.